Alright, welcome Year 10s to Lesson 8. So we're going to be solving simultaneous equations graphically. So we're going to look at what simultaneous equations are and how to solve them on a Cartesian plane. Our WALT for this lesson is to define simultaneous equations and solve simultaneous equations using graphical methods. So there's a few methods, but we're focusing on graphs for this lesson. So I want you guys to have a clear setting out of the question. And then you're going to have appropriate axes on each of your graphs. So once again, you're not going to have really long y-axes and really tiny x-axes. You're going to make it appropriate. This is because simultaneous equations are used to solve problems with multiple variables. Because often when we're modeling real-life situations, like the weather, there's more than one variable occurring. And if we want to get an equation for a single variable, or get some values for a variable in particular, we're going to have to do a lot of complex computing, and all of that is based upon simultaneous equations. When a point lies on two different equations, the equations are referred to as simultaneous equations. To solve a set of simultaneous equations means to find the point that lies on both of the equations. Simultaneous equations can be solved graphically or algebraically. So for this little diagram here, our solution to our simultaneous equations is this point of intersection just here, because that lies along the red line and along the blue line. So the solution to a pair of simultaneous equations can be found by graphing the two equations and identifying the coordinates of the point of intersection. So in our example, on the bottom right, what is the point of intersection? So what is the solution for those two simultaneous equations? So pause the video and see if you can find the solution. So the answer is -1, 1. So that means our coordinate is go to -1 on the x-axis, then move up to 1 on the y-axis, because this point here is on both of the equations. So that is our graphical solution to our simultaneous equations. So I want you guys to use the graph on the bottom right to determine the point of intersection and hence the solution of that pair of simultaneous equations. So this pair here. So I've already given you the graph in this case, but before we graph, we always have to rearrange the equations so they are in the form y equals mx plus c. So pause the video and see if you can find the solution to these two simultaneous equations on this graph here. So the solution is 2, 1. So that means go across 2 in the positive direction for x and go up 1 in the positive direction for y. Because this point just here is on both lines. It's the point of intersection. So solving graphically, that's really all we're doing. We're graphing our equations and then we're seeing where they overlap. And that point of intersection is our solution. One thing we can do with simultaneous equations is to check whether a given pair of coordinates is a solution to a pair of simultaneous equations. So we're going to check if the coordinate 5, -2 is a solution to the following two simultaneous equations. Now, we can do so without graphing, and that's the technique we're going to go through. Right, so we're going to check if the coordinates 5, -2 are a solution to these two simultaneous equations. And we're going to do it without graphing them. So first of all, I've labeled equation 1 and equation 2. And what we're going to do is we're going to substitute in these coordinates into each of those equations to see if they add up, to see if they make sense. So for equation 1, I've just rewritten equation 1, but everywhere there's an x, I've done a 5 instead. Everywhere there's a y, I've done a negative 2 instead. So I'm going to see if my left-hand side is equal to my right-hand side. So, evaluating that out, 19 equals 19. That is true. So my left-hand side equals my right-hand side. So this works for equation 1. So now I have to see if it works for equation 2. So everywhere there's a y in equation 2, I've written a negative 2 instead. Everywhere there's an x, I've written a positive 5 instead. And I'm still writing my equals 3 because it's part of my equation. Now I'm going to see if this evaluates and if we get the same result. So, turns out my left-hand side is equal to my right-hand side, so it works for this as well. So now I can confidently say that this is a solution. So it is a solution. So what that means is if we plotted both of these, this would be the point of intersection. So that's how this would look graphically. And algebraically, this is how we get there. And really quickly, if you end up with 18 equals 19, or something that's not equal, and you've done the algebra correct, then it's not a solution. As seen in that demonstration, if the left-hand side equals the right-hand side for each equation, then the coordinates are a solution to the simultaneous equations. That's it for this lesson. So I want you guys to complete the worksheet solving simultaneous equations graphically. Now, using graphs to solve simultaneous equations is the easiest way. Once you've got those graphs set up and you've got them in the correct equations in the correct format to graph them, it's very easy to solve them because you're just looking for the point of intersection. So once you are graphing, it's always handy to create that table of values so you don't accidentally get the equation in the wrong spot because that could affect your answer. Once again, if you have any questions, you can email me, post on the OneNote, or post in the Teams in that questions tab. So good luck. See you later.